Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel and it also helps us reach others in need of assistance with these topics. So in today's video, we're going to be covering problem 2.2 in Hibbeler statics, and we're going to be utilizing the parallelogram law to solve this problem. So what we have here is this picture on the left with this bracket, and it says if the magnitude of the resultant force is to be 500 newtons directed along the positive y-axis, meaning we're going to have something that looks like this. So the combination of these two forces of 700 newtons and F will create a resultant force along the y-axis here of 500 newtons. It is asking to determine what F causes that and what angle theta makes that happen. So we have to find F and theta such that when it combines with the 700 other Newton component force, it creates a resultant force, a singular force along the y-axis of 500 newtons. So we're going to be using the parallelogram law here because Hibbeler statics in problem 2.2, that section is using the parallelogram law. There would be an easier way, which is the rectangular components method, which we can talk about later when we get into later problems. So first thing we want to do is create a free body diagram with our forces. So we are going to make our x and y axis here. This is our 700 Newton force down here. This is 15 degrees off of the y. From the picture, this is theta. This is our unknown force F. And we have our resultant, if it wants to cooperate with me, right along the y-axis in the positive direction. I'll make that a little bit thicker there so you can actually see it. And that would be 500 newtons here. So when you have the parallelogram law, pretty much when you start out normally, you will know your two component forces and you try to determine what the resultant force is and what its angle off of the x direction or y axis is. In this particular problem, we are given the resultant force and one of the component forces, which our component force is the 700 and the other is the F, which we don't know what the F force is. So we kind of have to work backwards in this case from a normal parallelogram rule or law problem. And it's not going to be as, or that much trickier to work with. We still make our parallelogram, which is our beginning portion here. So in order to make your parallelogram, what you're going to do is you are going to copy your forces, your component forces, and you're going to paste them on the other component force. So for instance, I am copying my F component in blue, and you're going to place it and paste it at the end of the other component force. Then you're going to repeat that process for your other component. So with the 700 component, I am going to copy and paste it in blue to the end of my other component force, which is my F, and you should get a nice little parallelogram here. Now, what is wrong with this picture? Well, what is wrong with this picture is that the resultant force should, in theory, go to the point where your two components collide. It should be from starting point where your two components start and then where the two paste components collide. Now, in this particular problem, the reason why it is not going to be like this is because we are not to scale. We're not to scale at all. So if you had everything to scale, this is what your component's parallelogram with your resultant force from corner to corner would look like. But we are told it has to be along the y-axis. And the reason why it's not to scale is because we have no idea what that F force actually is. So what we're going to do is some manipulation here, and we are going to force this parallelogram to look like this. Now it's going to be kind of funky because it's not to scale because we don't know what the F is. So if we really wanted to make it work, we could force our F to be a little bit larger. For instance, it would look something like this, where we could change that F force. Let me unflatten here real quick. We could change that F force such that it, oh, sorry, it's grouped. We could change this F force and draw it so that we could be to scale, but you don't really have to do that. But we're going to make it a little bit better to see here. So there is my blue force now. And see how it kind of aligns? And then the 700 force would be something like this. So that would be our closer to scale parallelogram. So hopefully you understand the reasoning why we moved that and why we switched that a little bit there. Because if we look at our copied version here, this would be our F force here, and this is our 700 newtons right here. So, looking at our parallelogram, we have a lot of things to determine here. We have to determine some interior angles here, and we have to determine our force F. Now, we're going to work on force F first. So how are we going to do that first? Well, with the parallelogram, because the resultant force is splitting it, we can take two triangles here. We have this bottom left version triangle here and this upper left version over here. Because it is a parallelogram, it doesn't really matter which one you choose. One might be easier than the other. It's just up to you what you want to do. So what I'm going to do is I'm going to pull out the bottom one real quick. And we have our force F. This is our 700 Newton side, and this is our resultant, which is 500 Newtons. And if we were to put our X and Y axis here, we would say that this is 15 degrees right here, and this is 90 degrees right there because the X and Y. So looking at this triangle right now, we can determine that this interior angle right here, because of the 90 and the 15, this interior angle is a total of 105 degrees, which is important to understand. Because when you're using the parallelogram rule or law in a problem, you will most likely have to either use the law of cosines to solve a triangle or the law of sines to solve a triangle. Sometimes you have to use, and most of the time you have to use both of these laws from geometry, but if you can try to just use the law of sines, a little bit easier, but with the way these problems are set up, you'll have to use probably both of these laws. So the law of sines states that you know two interior angles and you know one side that's opposite that. Or you know two sides and one interior angle that's opposite. So what this means is that we know the 105 degrees, we don't know the side that's opposite that. So what that means, in order to use the law of sines, for 700 newtons, we would have to know this angle up here because it's the opposite angle. We don't know that angle. If we wanted to use the law of sines again, we could use 500 newtons with this angle over here that's opposite 500, but once again, we don't know what that is. So we would be stuck if we use the law of sines. Anytime you get stuck using the law of sines, you want to use the law of cosines. And the law of cosines state that you can know all sides or not know an interior angle, or you can know two sides with an interior angle, and that opposite side is unknown. So look what we have here. We have two sides that are known, an interior angle that is known, and the side that's opposite that interior angle that's unknown. This is what happens most of the time with parallelogram rule, is that you will set up this for the law of cosines. So let's fill this out. So I'm going to put it right here, right down here in this little pocket. So we would have our unknown side of f is equal to the other two sides squared. So 700 squared plus 500 squared. Subtracting off 2 times both of those sides, so times 700 times 500 newtons, and then multiplied by the cosine of the angle that's opposite my unknown side, which is cosine of 105 degrees. And then please do not forget the square root. That was supposed to be a nice straight line, but you know, when you freehand stuff. So that's a big issue, is a lot of people forget the square root. Don't forget that square root. So easy mathematics here, just plug into the calculator and we get 959.8 newtons in that general upright direction. So we have found what force is required to create the 500 newtons directly along the line. So we have found one item. The next thing we would have to find what theta is. So how are we going to find theta? Well, this is where we're going to use the law of sines in order to find theta. So if we look at the total parallelogram, we could use some interior sides here. We could use the law of sines for this little triangle to solve our interior forces, but what we're looking for is this angle right here. So in theory, what we want to do is we want to find out what is this angle right here and just subtract 90 off of it. Well, we do know that this angle right here is 105 degrees, right? Well, how does it help us knowing that that angle is 105 degrees? Well, if we look at our overall triangle, our overall parallelogram here, we can determine what this angle here is. Because a parallelogram, we have really four interior angles, but truly, two of these are going to be exactly the same. If we call this angle C, this would have to be angle C, which is between the F and 700, between the F and 700. And this angle up here, which, you know, we can call B, for instance, that's going to be exactly the same angle as this angle down here, because it, once again, is between the F and 700 crossing over the resultant force. So if we can get this entire angle of B, we can basically subtract 105 degrees from it. That would give us our question mark angle, and then subtract 90 from that to give us theta. So there are multiple ways that you can typically get these angles once you get the result or once you get one of the forces. And that's just using law of sines and using whatever theory that you feel best using geometry. In this particular case, what we're going to do is we're going to get the angle C, and then we're going to get angle B, and then we're going to get the question mark angle, and then finally we're going to get theta. So let's work on that. So utilizing the law of sines here, using this triangle over here that I pulled out earlier, because this is angle C, using the law of sines, what I'm going to have here is I'm going to have the sine of my 105 degrees over the side that is opposite it, which is F, which I just found to be 959.8 newtons, must be equal to the sine of angle C divided by the side that is opposite it, which is the 500 newtons. So rearranging and solving for C, simple algebra here, we'd have the sine inverse of 500 sine of 105 degrees divided by my 959.8 newtons after I cross multiply everything. And make sure your calculators are in degrees when you're working these problems, not radians. You would have 30.21 degrees. So that means that this angle right here is 30.21 degrees. This angle over here, since it is a parallelogram, they're going to be equal. This is 30.21 degrees. So how does that help us get the angle B? Well, a parallelogram is just a four-sided shape. All four-sided shapes have a total of 360 degrees. So my B is going to be equal to 360 degrees, subtracting off two of those C angles because they occur in two spots within the parallelogram. And then since there are two B angles that are opposite and equal there, we just divide by 2. And we would end up with 149.79 degrees. So this total angle right here is 149.79 degrees. Well, I know that this angle right here, part of B is 105, so I can get that question mark angle, which my question mark angle, which I'm just going to literally say question mark, is equal to 149.79 degrees, subtracting off 105 degrees, and I end up with 44.79 degrees. And then finally my theta angle, which will just be 90 minus my question mark, which is just 90 degrees, minus off 44.79 degrees. And that gives me a total of 45.21 degrees, which is my other answer that I need. So in the end, my F force would look something like this. If I draw my X and Y axis here, I would have my F force at 959.8 newtons, and it would be 45.21 degrees off of that x-axis, and that would be my overall answer to what F force at what angle makes the resultant of 500 newtons occur in the positive y direction. Now, as I said earlier, multiple different ways you can utilize the parallelogram rule to solve these problems. Pretty much you're either going to use the law of cosines at a start and then move to the law of sines. And once you get your force, you open up a lot of different avenues that you can walk through and you can go through to get the angles. It's not just cut and dry like this, where you can just, this is the only method that you have to use and the only path you have to use to get to that angle. Once you get the force, you can use geometry to find which way you want to do it. It's just, this is one possible way to get to that final answer there. But that's how you would work problem 2.2 in Hibbeler statics. So I hope this video was helpful. And if you want to see more problems solved this variety, please check out the other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of this helps us out greatly. Thank you for watching, and I hope you have a fantastic day.